Welcome to today's deep dive. You know, when you watch a live 4K broadcast of a stadium event, it feels like simple plumbing, right? A camera points at the field, a physical cable runs out to a truck, and then bam, pristine image on your screen.
Yeah. But behind the scenes, there's actually this desperate scramble. Broadcasters are trying to translate those physical video feeds into just, pure, invisible network data.
Which brings us to our mission for you today. We're decoding how the industry flawlessly moves that massive 4K video into modern IP networks without dropping a single frame. And the linchpin here is this, well, seemingly boring piece of elite gear we're looking at from our sources.
Right. The AJA IP25-R video converter, it retails for around $4,000. And it's a massive data logistics challenge to do what this box does.
Yeah, I mean, I look at this device like a high-speed, zero-latency UN translator, because instead of spoken languages, it's taking traditional 12G SDI and HDMI signals and translating them into the SMPTE ST2110 IP network standard.
Exactly. And translating 4K DCI resolution at 60 frames per second, that's just a relentless fire hose of information.
It's huge.
It really is. Broadcasters are rushing toward IP networks for the scalability, but they just can't justify throwing away millions of dollars worth of legacy cameras and switchers.
Right, so the IP25s acts as the translator so they don't have to overhaul their entire physical infrastructure at once. But bridging those two worlds obviously requires some heavy processing. And looking at the specs, I mean, honestly, I don't entirely buy it.
How so?
Well, you can't just download more RAM on a laptop to make it physically faster. So how does a simple free firmware update, this V2.0 update, magically double the physical video processing power of a piece of hardware literally overnight?
So that comes down to the architecture of modern broadcast gear. Devices like this rely on FPGAs.
Wait, FP, right?
FPGAs, field programmable gate arrays. They're essentially blank slate silicon chips. So when AJA released that free V2.0 update, they weren't just tweaking software.
Oh, interesting.
Yeah, they were literally rewiring the physical processing pathways on the chip itself using code.
That is wild. So the original unit was basically just a powerful receiver, but rewiring the chip introduces a brand new transmit or TX mode.
Exactly. It can suddenly take up to four 12G-SDI inputs and convert them into the ST2110 IP format with, frame-accurate synchronization.
Wow.
And it also expanded the receive mode from handling 4 streams to 6 streams of IP video. So the physical box sitting on the server rack is identical, but its digital brain was totally remapped.
It really shows how software-defined the broadcast industry has become. But wait, pushing all that heavy 4K data both ways across an IP network introduces a huge vulnerability, doesn't it?
Oh, absolutely. Packet loss is the core nightmare for broadcast engineers.
Because an IP network isn't a locked physical cable. If the network drops packets during a Super Bowl broadcast, the whole feed just crashes.
Right, which is exactly why they use dual 10 or 25 GigE SFP cages. These are modular slots for optical transceivers, so fiber optic cables can carry those massive IP loads.
So having dual cages is kind of like having a perfectly synchronized stunt double running right beside you in an action movie?
That's a great way to put it.
Thanks. It's like the camera is filming both of you at the exact same time, frame for frame, and if you trip, the director just cuts to the stunt double in a millisecond, and the audience never notices a thing.
Yes, exactly. In the industry, we call that the ST2022-7 protocol. It sends identical redundant data down 2 completely separate network paths simultaneously.
So if one path hiccups, the receiver just grabs the missing data from the backup path.
Instantly, it provides seamless protection switching, which is just mandatory in these high-stakes live environments like network operations centers or OB trucks.
So the next time you are sitting on your couch watching a flawless live 4K broadcast, take a second to consider the invisible, ultra-low latency bridges making it happen right behind the scenes.
It really does force you to look past the picture and appreciate the sheer data architecture required to deliver it to your screen.
It does, which leaves us with this final thought for you to chew on.
If the capabilities of physical broadcast hardware can essentially double overnight just by rewiring an FPGA through a free software update, how long until physical video ports and cables disappear entirely, leaving us with nothing but pure, invisible digital oceans of network connections?